Hello, and welcome back to the System Design series. At a high level, we can categorize the design goals into 5 different categories. In the previous video, we covered performance-based design goals. In this video, we will continue and dig into dependability-based design goals. This category of design goals helps us to make a system more reliable from an operational standpoint. So how can we describe dependability? Dependability refers the effort required to minimize system crashes and malfunctions by making the system more available, reliable, and fault-tolerant. This category has many criteria that we can look into in order to define the design goals. We will start with an important criteria called as availability. Availability is the time a system remains operational to perform its required function in a specific period of time. It is a simple measure of the percentage of time that a system remains operational under normal conditions. Availability is often quantified by uptime or downtime as a percentage of the time the service is available. It is generally measured in the number of nines. For example, if we say the availability of system is 99.00%, it's said to have 2 nines of availability. And if it's 99.9%, it is called as 3 nines, and so on. Availability helps us to answer the following question: what percentage of time the system is available to perform normal tasks? As a design goal, we want to maximize the availability of a system, that is to make our system highly available. We can increase availability for our systems by building our system with failure in mind. For example, a load balancer acts as a reverse proxy and distributes traffic among several servers to reduce excessive load on a single one. This increases the capacity of our application and reduces downtime. High availability load balancing is crucial in preventing components failure and massive outages. So our design goal should be to architect a system that optimizes for increase in availability. Reliability. Reliability is the probability that a system performs correctly during a specified time duration. During this period where the system is operating correctly, no repairs are required or performed. The system adequately follows the defined performance specifications. Reliability can be expressed as the difference between the specified and the observed behavior. Let me take a very classic example from our day-to-day life in order to understand this better. A car's reliability is measured by how many unplanned breakdowns it has. As long as you keep up with the regular service like oil changes, new tires, brakes, etc., a reliable car will not break down on you. By contrast, an unreliable car will break down on you no matter how well you take care of it. Reliability is a very important concern for every system, including software-based systems. No one wants to use a non-reliable system, especially for critical functions that may be time-bound. We now know a lot more about availability and reliability. Let's see how these two design goals relate to each other. If a system is reliable, it is available. But if it is available, it is not necessarily reliable. In other words, high reliability contributes to high availability, but it is possible to achieve high availability even with an unreliable system. As a design goal, we want to maximize the reliability of a system, that is to make a system highly reliable. Fault tolerance. How do our systems operate under normal error conditions of fault? This is expressed as fault tolerance. Fault tolerance is the availability of a system to continue operating without interruption when one or more of its components fail. Let's understand this with an example. We can use a load balancer to distribute load across a server farm, and if any of the server fails, the load balancer can detect that failure and remove the server from its pool of healthy servers. This failed server can later be replaced with another healthy server automatically. This would ensure a system keeps on functioning without interruption. As another example, we can make provisions for backup and replicate our data from a primary database to another secondary server that can be used for failover. When the primary server dies due to some system fault, the secondary server becomes the primary and our service continues with normal operations. Fault tolerance is a very important set of design goals that make sure a system can perform irrespective of any faults that may arise during normal operations. Let's compare high availability versus fault tolerance. Both high availability and fault tolerance apply to the methods for providing high uptime levels. However, they both accomplish the objective a little bit differently. A fault tolerant system has no service interruption but a significant higher cost, while a highly available system has minimal service interruption. Fault tolerance requires full hardware redundancy because when the main system fails, we want the backup system to take over with no loss in uptime. As a design goal, we want to maximize fault tolerance, that is the ability for a system to handle any fault that may occur, quickly recover from it, and function without service interruption. That's all for this video. In the next one, we will cover other design goal categories, namely cost, maintenance, and end user criteria. Please subscribe to our channel and click on the bell icon to get notified whenever a new video is posted. Till then, keep learning, and I will see you in the next video.